Well, now our task is to simplify this expression. And remember, I is an imaginary number and equals the square root of -1. So now we have 5, and we can go ahead and drop these parentheses, and we have 5, and plus times a minus is a -6, and plus 1 times a -6i is a -6i. And now 5 minus 6, they're like terms, so the difference of those two is -1 and -6i, and we are done. And now we have 3i, question 2 times 8, or -8i, and that equals, well, the product's going to be negative, because a negative times a positive is negative, and we get 3 times 8 is 24, and I times I is I squared, but keep in mind that I squared equals -1. So that's going to be -24 times -1, which equals 24. And we're done. Well, our task now is to simplify this difference, product and difference. So we know this, that I squared equals -1. Now we have -6i times 3, and -6 times 3 is -18, and we have this factor I. Now -6 times -6i times -2i is going to be a positive 12, and that's going to be I squared. I times I is I squared. And now let's move on, and we have 7 times 4 is 28, and I times I is I squared. Now let's simplify this, and we get -18i, and I squared is -1, so that's going to become a -12, because 12 times -1 is -12. And now we have 28 times -1, I squared is -1, and a negative times a negative is positive, so that's going to be plus 28. Now keep in mind, when we write our final answer, it has to be in standard form. A plus bi, where the real part's first, the imaginary part second, and 2 separate terms. So let's see. We have -12 plus 28, that is 16. And minus 18i. Good, real part first, imaginary part second, 2 separate terms, and we're done. Well, finally, we've got this quotient to resolve. And in order to do this, we're going to use the property a plus bi times a minus bi. And the product of complex conjugates is, when you FOIL this out, you get a times a, which is a squared. The middle term's going to add out, because you get a plus bi, a times bi times a minus bi, and so the middle term adds out, and finally you get minus bi squared, but I squared is -1, so ultimately you get a squared plus b squared. Well, with that in mind, and notice the I is gone. With that in mind, we're going to multiply by 1 in the form of the complex conjugate, a plus 5i over, or excuse me, 1 plus 5i over 1 plus 5i, which is another way to write 1. And So that's going to equal downstairs. All we have to do is square 1, get 1, put a plus sign, square 5, and get 25. Notice we're adhering to what we have here. Now, upstairs we get 9i times 1 is 9i, and 9i times 5i is 45i squared. Now we have 26 downstairs, 1 and 25. And we'll put the, now let's see, this is going to be I squared, so that's 9i, and I squared's minus 1, so that's minus 45. Now, we have to write two separate terms in the form of a plus bi, real part first, imaginary part second, two separate terms. So that'll be negative 45 over 26 plus 9 over 26, and we'll stick a nice big I there. And we are done. Notice nothing reduces here. The only factors of 26 are 2 and 13. And so nothing's going to divide out, and we are done.